thing that we are going to find, that we are going to read is angle between two planes. The procedure when two planes will be given and to find the angle between the planes, the first step will be obtain the normal vectors n1 and n2 of these planes, and then the second step will be cos theta will be equal to n1 dot n2 over n1 magnitude into n2 magnitude. From there you will find the angle between the two planes. So here is a question that will make your concepts more clear about this topic. So look now. Find the acute angle between the planes x plus y minus 2c is equal to 5 and 2x plus 3y minus c is equal to 1. So two planes are given. So the normal vector n1 of first plane is 1, 1 minus 2, and n2 will be 2, 3 minus 1. Okay, this is n2. Okay, now we will find n1 dot n2. So n1 dot n2. So respective I component, j component and k component will be multiplied. So 2 ones are 2 plus 3 and plus 2. So that is equal to 5 plus 2, 7. Now we will find the n1 magnitude and n2 magnitude. So 1 plus 1 plus 4. That is 6 square root. And now n2 magnitude. That is 4, 9 and 1. So this is 14 square root. And finally putting the values into the formula. So first we will write the formula. Cos theta is equal to n1 dot n2 over n1 magnitude into n2 magnitude. So now we are going to put the values into the formula. n1 dot n2 is 7 over n1 magnitude is square root 6 and n2 magnitude is square root 14. So now the theta will be equal to cos inverse of 7 over square root 6 into square root 14. So now we will solve it. So shift cos bracket start 7 divided by 84 square root bracket close. So the answer is 40.20. So this is the angle between the two planes. The next thing that we are going to read is the angle between a plane and a line. So the steps when a plane and a line will be given and the requirement was to find the angle between line and plane. First step will be we will obtain the normal vector n from the plane and the direction vector b of the line. Then step 2 will be cos theta will be n dot b over n magnitude b magnitude. And the step 3, if the requirement will be obtuse angle, then theta minus 90 degree will be done. And if acute angle will be required, then 90 minus theta will be required will be done. So look now, find the angle between the plane 2x plus y plus 3z is equal to 5 and the line r is equal to 6i. So this is the line. So look now the solution. The normal vector is 2, 1, 3 and the direction vector of the line is 2 minus 3 minus 2. Okay. The next thing that we will do, so this thing that is n dot b will be is required. So we are going to do n dot b. So that is 4 minus 3 and minus 6. So minus 9 plus 4 is minus 5. The next thing that is required is n magnitude and p magnitude. So n magnitude is 4 plus 1 plus 9 square root, that is 14 square root, and then p magnitude is 4 plus 9 plus 4. So 8 plus 9, 17 square root. And finally, we are going to put these values into the formula. So look now, cos theta is equal to n dot b over n magnitude into b magnitude. So putting values into the formula, n dot b is minus 5 over n magnitude is 14 square root, and b magnitude is 17 square root. So cos will be negative. So cos will be negative, that will be obtuse angle. So the function of the minus sign was to tell us the obtuse angle. So now we will find the theta. So putting values into the formula. So now cos inverse. So the answer is 108.9 degree. Okay, because this is obtuse angle, so the required angle will be theta minus 90 degree. So theta is 108.9 degree minus 90 degree. That will be equal to 18.9 degree is the required angle. The next thing that we are going to read is the perpendicular distance of a point from a plane. So very important. So concentrate yourself. Find the foot of the perpendicular of the point. Here is the point from the plane, and here is the plane. Hence obtain the perpendicular distance. So look now, I'm going to tell you a direct method. So put x is equal to y is equal to 0 in the plane. Here is plane 5x minus 4y plus c is equal to 8. So when we will put x is equal to 0 and y is equal to 0, so z will become 8. Okay. The next thing that we are going to read in the topic of vectors is the perpendicular distance of a point from a plane. And here is a question that will make your concepts more clear. So concentrate yourself. The question is, find the foot of the perpendicular of the point I minus 2j minus 3k from the plane 5x minus 4y plus z is equal to 8. So the first step in this kind of question where perpendicular distance of a point from a plane is required. So first we will find OA by setting x is equal to y is equal to 0 in the plane, that is 5x minus 4y plus z is equal to 8. So look now, from here when x is equal to y is equal to 0 will be set in this plane. So z will be equal to 8 because this factor and this factor will become 0. So z will be 8 and OA will become 0, 0. So because x and y are 0 and z is 8, so OA is 0, 0, 8. So the next thing that we will find is AP vector, that is obtained by OP minus OA. So look now, OP is the position vector of the point, that is 1 minus 2 minus 3. And minus OA is 008. From here, 1 minus 0 will be 1, minus 2 minus 0 will be minus 2, and minus 3 minus 8 will be minus 11. So this is AP vector. Okay, the next thing that is required is the normal vector. The normal vector is 5 minus 4 1. Okay, the next thing that is required is n magnitude. That will be equal to 25 plus 16 plus 1, because the magnitude's formula is x square plus y square plus z square whole square root. So from here, 25 plus 6, 31, 41 and 42 square root. Okay, finally we are in the final stages. So AP dot n is required. So here is AP 1 minus 2 minus 11 dot normal vector, and here is normal vector 5 minus 4 1. So from here you can see 5 plus 8 and minus 11. So 5 plus 8 13, minus 11 is 2. Okay, now we are going to put the values into the formula. So finally we are going to put these values into the formula. So QP magnitude is equal to AP dot n modulus over n magnitude. So putting values into the formula, AP dot n is 2 and n magnitude is 42 square root. And because this is the perpendicular distance, so that's why units will be written with it. So this is the answer. The next thing that we are going to read is the intersection of the two planes. So look now, this question will make your concepts more clear. Find the vector equation of the line of the intersection of the planes, and here are two planes. So the method to solve this kind of question is, first we will find the normal vectors of the two planes. So n1 is 1 1 minus 3 and n2 is 2 minus 1 1. Okay, so first we will find the direction vector of the line that is intersecting the two planes. That will be equal to B is equal to n1 cross product n2. So that will be equal to I j k 1 1 minus 3 and 2 minus 1 1. Okay, from here I will be, okay, I will be 1 minus 3 minus 1 1 minus j into 1 minus 3 2 1 and plus k will be 1 1 2 minus 1. So from here I into 1 minus 3 minus j into 1 plus 6 and plus k into minus 1 minus 2. So that will be minus 2i minus 7j minus 3k. So this is the direction vector of the line that will intersect the two planes. Okay. Now to obtain A, set x is equal to 0 in the planes. So the equations will become now y minus 3z is equal to 6 and minus y plus z is equal to 4. Okay, at this stage adding these two equations, so this will be equation number 1 and 2. So adding them, this will cancel. So minus 2z will be equal to 10 and z will be equal to minus 5. Okay, putting value into any one of the equations. So suppose we will put here minus 5. So y will be equal to minus 5 minus 4. So y will be equal to minus 9. So it means a will be 0, y is minus 9 and z is minus 5. So this is a, and now the equation of the line will be r is equal to a plus lambda b. So a is 0 minus 9 minus 5 plus lambda as it is, and b is, so here is b, minus 2 minus 7 and minus 3. So this is the equation of the line that is intersecting the planes.